Cholesterol levels. Too much cholesterol in the blood indicates the risk of developing heart disease. The total cholesterol levels of young women is approximately normally distributed, normal distribution with a mean of 185 and the standard deviation of 39, while that for the middle-aged men is normally distributed also with a mean of 222 and the standard deviation of 37. Julie's total cholesterol is 245 and her father's is 270. Determine methodically who is at a higher risk of developing heart disease. With any continuous probability distribution, we first need to draw a graph. In this case, we need to draw two bell-shaped curves for two normal distribution. For Julie's or young woman, the cholesterol level is normally distributed with the mean of 185 and the standard deviation of 39. And this is for young woman. For middle-aged men, the cholesterol level is normally distributed with the mean of 222 and the standard deviation of 37. In most cases, we might have to label this as mu sub x, sigma sub x, mu sub y, sigma sub y, for example, or mu sub 1, sigma sub 1, mu sub 2, sigma sub 2 to differentiate the two. Now, Julie's cholesterol level is 245 and that is above the mean. We would label 245. Usually, we would draw the vertical line on the normal bell-shaped curve to indicate the value. For Julie's father, his cholesterol level is 270, which is also above the mean. Comparing Julie's cholesterol to her father's cholesterol level is similar to comparing apple to oranges. We can't compare the two because one is for young women and the other one is for middle-aged men. To compare the two, we need to somehow turn them into the same standard. And one way to do that is to standardize their cholesterol level using the formula Z equals X minus mu over sigma. This is called the Z-score or the standardized Z-score. And so for Julie's, the Z-score is 245 minus 185 divided by 39. And this will give us 1.54. For Julie's father, the Z-score is 270, the given value x, minus the mean, 222, divided by the standard deviation, 37. And this is 1.30. Now, the higher the cholesterol level, the higher risk of developing heart disease. And so if we were to compare 1.54 and 1.30 after we standardize these values, 245 and 270 respectively, we see that Julie's is at a higher risk than her father. This is surprising because, again, Julie's cholesterol is only 245 and her father's is 270. If we were to look at these two numbers, we cannot compare them. We have to standardize them. Once we standardize them, then these two numbers represent the same scale, and so we can compare the two. And again, in conclusion, we say that Julie's is at a higher risk of developing heart disease because Julie's cholesterol level is higher compared to her peers, her group, young woman, compared to that of her dad, relatively to his peers, middle-aged men.